All right, so I had some technical difficulties there, so I'm kind of coming back to this page, and where we were at the probability of being a 70 or a C, of getting a C. So I think we had already done this, but I'm going to go ahead and do it again. So the probability of getting a C or better would be the probability that we get a 7 or an 8 or 9 or a 10 out of 10, and so that's greater than or equal to 7. But we cannot get greater than or equal to from our calculator, so not on a TI. And therefore what we have to do is we have to say that this is 1 minus the probability of getting less than a 7. But again, our calculator doesn't do strictly less than, right? Our calculator does less than or equal to. So we will make this 1 minus the probability that x is less than or equal to a 6. So remember here's the 7 bar, right? And then the 6 bar is over here. Oops, 6 bar is over here, and the 7 bar is here. If we want to be strictly less than the 7 bar, then we're starting at the top of the 6 bar, bottom of the 7 bar, and going this way. So this would be the 6 bar, the 5 bar, the 4 bar, so on and so forth. So our calculator can take care of this. So this is binomial CDF, and then we have our 10 trials. And then we have a probability of success of 1/5 or 0.2, and then we have a 6. Now remember, don't forget that this has to be a CDF. So this is 1 minus point, and I'm going to do my CDF function, and I have 10, and then comma, and 0.2, and then comma and 6, and then I get this value here, 0.9991356, and then 416 if I wanted to go that far. So if I did all of these numbers that I have here, this would be point, and then 0, 0, 0, 8, and then 6, and then 4, and then 3, and 5, and 8, and then a 4. And then I have to round this to 3 significant, so these zeros don't count, so 3 significant, there's 3 of them, so I'll have to round it to right there, so that this would be approximately 0.000864. That's a pretty slim chance that you'll pass the test if you come in guessing, right? Definitely way less than your 0.05, which is what's considered to be unusual. So that's not a very good thing to do, is to come into a multiple choice test guessing. All right, now what's the probability that the student will flat out get an A? Well, the probability of getting an A, there's 2 ways of getting an A. That's being a 9 or a 10, so that's greater than or equal to a 9. Because remember, a 9 out of 10 is a 90%, and a 90% is an A. But getting 10 out of 10 is also an A, so 10 out of 10 being 100%, right? Those are both A's. So again, we can't figure out greater than or equal to on our TI, so this is not TI capable. So we have to do the complement again. So this is 1 minus the probability that x is less than 9, so greater than or equal to, so strictly less than here, right? This is our 9, and this is our 8 here, and so we're wanting to be strictly less than 9, so it's the 8 or less. So this is 1 minus the probability that x is less than or equal to 8. Now on our TI calculator, we'd put this in as the binomial CDF. Don't forget, it's got to be the CDF, right? And our number of trials is the 10 questions. Probability of success is 0.2, and then we have 8 or fewer, so we put in 8. So I have on this we have 0.999. Let's see, there's 5 9s this time, and then a 5, and then an 8, and then a 0, and a 1, and a 6. And that's again complements, so 0.00000, and that's all 5 of those 9s, and then a 5, that would be a 4, and an 8, that would be a 1, and then 9, and then 8, and then 4. So rounding to 3 significant digits, that's rounding to right there, but that's going to round through, so this would be approximately 0.00000, and then we have 4, 2, 0, and that would be the probability. There's an even slimmer chance, right, that you would get an A on the exam if you came in guessing. That's what we would expect. All right, so now the next question that might arise is, what would a student get on this exam, what on average, when they would be testing? Or what would we expect them to get? Remember, expected value is nothing more than the mean. So what we'd want to find out here is, how do we find the mean and the standard deviation of a binomially distributed random variable? Now I believe in Triola's